So for this question, two masses are connected by a light string passing over a frictionless pulley, as shown, okay? The coefficient of friction between M1 and the horizontal surface is 0.35, while M2 is hanging, okay? You guys want to find the tension in the string attaching the two blocks, and assuming that M2 is being held onto until such time it gets let go, then the whole system's going to accelerate, okay? So that's what's going on here, and you want to be able to calculate what that acceleration actually is, okay? So much like this morning, what I like to do, anytime I see one of these questions that are kind of like mixed, from the standpoint of like x and y, what you could do is change this, like to do what I did this morning, right? Where we draw, here's one box, it's attached with a string to a smaller box, right? And after you've done that, you can draw on all your forces, right? So we could say this is 1.5 and this is the 0.8, okay? Now, what you can do, okay, I'll label this two different ways, okay, so that we make sense of it, okay? This is your free body diagram. You're just gonna start drawing forces on here, right? So we know on this 1.5 kilogram mass, it's in contact with the surface, so there must be a normal force, right? It's acting up. But then there's also the force of gravity acting on that, right? Just from the center, right? And we know as soon as this thing gets released, it's going to have motion in this direction, right? Motion in this direction. So we know that there's going to be a friction force backwards, right? And then you're going to have tension this way, okay? And keep in mind when you label your axes, you're going to positive, positive, negative, negative, like usual. I just like drawing that for everyone's reference, okay? And then once we look at that, we say, okay, I think that's pretty much it on the first box. On the second box is this is a nicer question from the standpoint that the second box is not touching a surface, right? And so we don't have any friction, right? There's no Fn, there's no friction. It's just gravity and the tension in the rope. That's what makes this question a little bit easier, right? With negative tension. And then this way we're going to have the force of gravity acting on that box. Everybody okay with the setup on that? Okay, now, depending on whether or not you choose to like that, like I find this is helpful. Let's just say you decide to just work with this. Well, I kind of have, it doesn't really matter, but let's just say you don't necessarily like switching this into one frame, right? Well, for one of the boxes, the interesting motion, this would be for box 2, right? Or the M2 box, right? The motion is happening in the Y direction, okay? And you could go through this and you just run through it, right? With the Y. But the problem is like, okay, well, M1 is dealing with all X's. Okay, and so like, I don't know, if you don't like working with two different directions, that's what this does for you. It takes the entire question and just puts it into like basically one dimension, right? Where we can just say, okay, M2 is now purely in the X direction as well, right? Like we have negative X's and we have positive X's. Okay, that's what this picture does for you. Okay, it just kind of puts everything in one singular line, and there's not so much, particularly with these questions where there is motion in the Y direction, you know, it makes things a little bit nicer. Okay, so if we're dealing with mass 2, we'll start with the easy one. Mass 2, well, let's just look at the forces. I'm going to add up the forces on mass 2, right? Well, I see negative tension and I see a positive force of gravity, right? So you say, okay, negative tension plus Fg is equal to ma. All right, well, we know the force of gravity is mg, so negative t plus mg is equal to ma, and just plug in some numbers. We don't know tension, unfortunately, right? But we're going to find that. So negative t plus 0.8 times 9.8 is equal to 0.8 times a. We don't know acceleration. Right? And so you say, okay, let's just set the problem up the same way we did this morning, right? Could say, okay, negative t 0.8 times 9.8, that should be 0. Where am I looking here? Sorry. I'm just looking on the wrong spot. 7.84. And that's going to equal 0.8a. Is everybody okay with that? It's nothing too. Why is gravity not negative? Chris, you could do it one of two ways, right? So if you look at my picture here, gravity, if I'm dealing with my picture, the one I changed, gravity's acting in the positive direction. Okay. If you're dealing in the y, Chris, then you can do something like this, right? If the box is like this, force of gravity would be, that's okay, buddy, that's okay. Force of gravity would be negative here, and the tension would be positive here. I think maybe why my physics teacher taught me this was because from a solving perspective, you guys can see, oh, this is nice. One of my tensions is negative, and one of them is positive this way. I suppose, yeah, that's the problem, Chris. If you look at this, if you try to do this question like this, we're going to have positive tension here, but if you did it in the x as well, tension's also going to be positive there. I don't know if that works out quite as well from a solving perspective, which is why maybe we do this. Okay, we just put everything in one line, and now the tensions look like, okay, I'm going to do elimination here, right? That's maybe why he's chosen to do that way back when. You guys got to remember, I did this course. You can see on some of the notes, I did this course, grade 12 physics, in 2010, which means I would have done grade, and I graduated in 2010, which means I would have probably done grade 11 physics in 2008 or 2009. Forever ago. Okay. So anyway, as long as we're all okay with this, okay, that's just we're doing the exact same thing for M1 now, right? I'm just going to add up the forces. Oops, I didn't mean to move that. I'm just going to add up the forces in the x direction for M1 now, right? Well, okay, a little bit more busy, but actually not too bad, right? I know tension, positive tension, right? And then negative force of friction is equal to MA. Okay? Positive tension. The problem with this time is that we have friction. We have minus mu Fn. Well, what is Fn? Fn is equal to Fg. So basically just mg. Okay, so you can take that and plug it in there, and that's going to be equal to Ma. So we go tension minus mu mg is equal to Ma. Right, it told you what mu was, you know what m is, and you know what g is. That's fine. Right, we're going to say tension minus mu will be 0.35. That's the coefficient of friction. And then the mass will be 1.5, and g will be 9.8, and that's going to be equal to 1.5a. Okay, so you just do the math here. We see, okay, t minus whatever the number is. Let me just cheat and look at my answer. Negative 5.15, if I've done that correctly. Okay, now look. This is why, Chris, I think we set it up this way. We have these two equations, one here and the second one here. And if I were to take this and drop it underneath here, look, something nice happens. Right? If I were to add these two equations together, I'm going to get 0t, and then you do the math here, 7.84 minus 5.15. Well, that should be 2 point something, 2.69, right, is equal to, what are you doing here? This is called collecting like terms. They're like terms because I have something A, right? You add them together, you should get 2.3A. And if I were to divide both sides by 2.3, I'll get A is equal to 1.17 meters per second squared. That's the acceleration of the whole system. It's a system because it's connected with that rope, right? And so what the acceleration one box feels, the other one has to feel. So we get one acceleration for the entire system there. And because it's one rope now, you guys can go back. You can pick, I'm going to use equation 2 to solve for tension because now I know A, right? So you say, okay, tension is equal to 1.5A. I'm just going to bring this over by the zero pair, right? 1.5A plus 5.15. So tension A, times 1.17. Right? If you do the math on that, you should get 6.9 newtons. So that's the tension in the string. Okay, does anybody have any questions with that? I told you that one was a little bit easier. Okay, more manageable. And I think some of it comes out of you just try to I try to avoid maybe doing the mixing of the Fy's and the X's, right? And I think in doing that, you get this, the math works out a little bit nicer where you get to come down here and just use elimination. Okay.